everyone. Today I would like to talk about my final year project. The topic of the project is design model of vegetated slope. Slope is a soil filled with incline geometry. Every slope has different composition of soil and dimension, and therefore each of them is unique. We can see soil slope in Hong Kong everywhere, like besides a road with vehicle traveling in this picture, and also near a residential area in the top picture. So, to investigate the stability is very important, as a stable slope can largely reduce the chance of having landslide, which is disastrous to human and cost many lives. If the landslide is happening besides a vehicle road, the landslide and the soil running down will damage the car and also block the road. If the landslide is happening besides the residential area, the building of the residential area will be destroyed, and also the human lives is threatened. Therefore, to stabilize a slope, there are two major current methods to be implemented to a soil slope, namely soil nail and retaining walls. In this picture, soil nails are the silver dots on the black soil slope, and also soil slope is embedded by a series of steel bars, making the soil particles packing closer, and thus making the slope more stable. The retaining walls on the top picture is a concrete wall that blocks the soil from falling along the slope, and therefore these two methods can prevent landslide from happening. However, there are drawbacks of these methods and they are not perfect. For the soil nail, the problem is that they will rust when the water in the soil slope corrodes them. When soil nail is rusted, the efficiency of them to stabilize the slope is largely reduced, and hence the stability of the slope cannot be increased. For retaining walls, it can cause serious ecological impact to the environment. The construction of retaining walls will emit carbon dioxide, which is a type of greenhouse gases, and it can aggravate the greenhouse effect and global warming. Therefore, to reduce the using of modern methods, a new method without the above drawbacks should be investigated, which is vegetation on slopes. Vegetation on slopes is embedding the root systems in slopes, which is having similar mechanism of soil nails. We can see that in this picture, the root system is growing in different directions with the roots embedded into the slope. The roots embedded act like the steel bars to enhance the stability of slopes. In this project, I will investigate the root models with different geometries of root systems, and also the geometry of slopes is different. And for the methodology, I will use the software SlopeW, which is engineering software to define the geometry of slopes and also define the background conditions. And the soil type is also can be defined. We can also define the background conditions acting on the slopes, like the seepage flowing in the slopes. For this project, I will use the software SlopeW to stimulate slopes with roots embedded. In this picture, the green part is the slope, and the orange part is the root system. We can use the software to stimulate the efficiency of the root system with different geometry of slopes, and also we can evaluate the effectiveness of them. Now, I will talk about the update on the progress and also the future plan of the project. For the stage now, I demonstrated the stability of slope with soil nail and retaining walls using the software SlopeW. And furthermore, I'm designing models with different geometry and loading conditions, and I will use the results generated from the software to compare the stability under different stabilizing methods to investigate the efficiency of root system. This is the end of my presentation. Thank you.